Okay, welcome back to the lab. Okay, so let's have a look at this week's lab. So we are asked to use the help RCT data. Fit models with the following variables. So we have the link status again. We have the covariate X1 treat, these are the treated or control, and with the covariate X2, which is the substance the individual was abusing, either alcohol, cocaine, or heroin. So we're building model 1 without interaction, and we're building model 2 with interaction, which is an X1, X2 model. And populating the following table and uploading our coded results. So firstly, in the same code, you will also have all these codes that have been part of the lab, and I alluded to those already, what they mean earlier during the lecture. So I'm just quickly walking through them. So we have now remove list ls, which we know already. We're setting the working directory to that folder on my desktop, which I encourage you to also create in the same fashion. We're loading library Haven and Stargazer, and we're loading the enhanced data set. So as you can see on the right, I've done that already, but I'll quickly load it again. So we have now fit1 and fit2. Fit1, the blood pressure as a function of age and gender. Fit2, blood pressure, age, gender, and the interaction between age and gender. You can look at this in a box plot. In the box plot, we're going to be seeing that there's a significant different blood pressure in as per gender, and we further can see now we further can see the relationship between blood pressure and age. That was something that came up in the last lab, and we can calculate the male entries. And then look at summary. We see the summaries for the different models already from the lecture. The Stargazer, we can bind it together and we can actually show it then next to each other in two columns. The code that came up with the last lab was the enhance subsetting as per only including those with no missing values. Enhance 2 here will become a subset of enhance, with that the exclamation mark indicates that there is everything contained that is not, is an A, essentially is now, is an A stands for is a missing value. We exclude everything that is not a missing value. Exclude everything that is a missing values and only leave the non-exclusive, non-missing values. So this is now true for blood pressure, exact age, male. This is logically OR. You will find this on top of the backslash. And this essentially means exclude everything that is a missing value of blood pressure or missing value of exact age or missing value of male. So then we have here plot. And hence 2, I'm using that now. So now plotted hence. But you can fit male and fit female. This can now shown as a line included here now in the plot. But you have seen all of this in the lecture. So same essentially is done here with enhance 3. This is the hypertension example where the blood pressure greater than 140. Fit 3 and fit 4. Again, male and EDU, and the interactions of male and EDU. As a package again, we're gonna put next to each other. Because now I know what we can compare now, whether this was significant. Building subsets, we can essentially then also look into in the various subset of educational level. We can look at this package again depicted right next to each other. To what extent gender is affected by college level or by education level. Good, but this is exactly what we discussed in the lecture, so this is less of a focus here. So the lab assignment here is from the help RCT data, as I mentioned before. We are being asked to fill out this table below. The background noise, that's my heating. So we have here this table to be filled out. Okay, how are we gonna do this? So we know that RCT needs to be loaded. The order, the folder is still defined. We can do a subset, the report RCT2. Model 1 is now essentially summary model 1, that's treatment, substance cocaine and heroin. Basically, we're seeing that only heroin is significant. We can, with contrast, we can see where the reference levels are, but we know that already it's control and alcohol, which is essentially what we are being asked here to do. Then we create the data frame. And this I briefly want to explain. So there are different ways to approach this. I do it with data frames. It doesn't necessarily mean it has to be done that way, but I like it that way. Okay, so essentially what you do, data frame will ask you to get those variables defined, the columns. The columns is here, condition, alcohol, cocaine, and heroin. This is condition, alcohol, cocaine, and heroin. They're separated from each other with a comma. So you see here. You're giving the number of entries here with control, treated and treated minus control, which is exactly what we need here. And the rest of it you fill up with an A. You need to fill those up, that's important. So we know that the first one, and this is now where we go, row 1, column 2. This is row 1, column 2. We're setting this to 0, right? Now we just need to populate all the other ones. And now I just want to show you how Marcel and Bino solves that. Well, it's quite clear what you need to do, right? You know that when you have treated for alcohol as a substance, the only thing you need to do is you need to understand how the summary model won't look like. And here we have, this is only going to be treat, right? So it's essentially we have this control with alcohol and control. So the only thing you need to fill out here in the treated cell, treat and treat, essentially can be extracted from summary model 1 with the summary model 1 coefficient command. So if we have summary model 1 coefficient, and we're saying, okay, so I want 1, you get 1. This is the intercept, but you don't want the intercept. You want the whole first row. And the whole first row you get was comma, leaving the first blank, because indicating all the rows. And after you say column 1, this gets you the first column. So now, what else do you want? You want only treatment. The other ones you knock off, right? But this one you don't need. Substance cocaine you don't need. Substance heroin you don't need. And you can do this, and this is quite elegant, and you will see this in a couple of contexts. You can multiply it by a vector that essentially multiplies this one by 0, this one by 1, this one by 0, and this one by 0. Only leaves this one over. When you sum this, you can actually get to, if we do this. Let's do this. Okay. This is not 0. This is 199. This is 0. This is 0. Okay. And now the only thing you need to do is you need to sum that up. You cannot sum it. You just need to take these names off. That's the problem. And this is what you do with a command here, unName. And by that, you basically get the sum of whatever you have developed. And this is just 1.9942. So now you're doing this, and you're basically ending up now with exactly this. 0, 1.99. Now you just, for treated minus control, you just need to subtract table without interaction, 2, minus table without interaction, 1, 2. Now exactly this overview. If you do now the same thing with cocaine, you take summary model 1, you take model 1 coefficient 3, 1. This is row 3, 1, 2, 3, 1. You see minus 0.038. True. 0.06. Now, if we do the same thing now we need different entries now, right? So with 0, that's the intercept for the treatment. Yes, we need treatment. Do we need cocaine? Yes, we need cocaine. Do we need heroin? No, we don't. So we build now the sum of that. That is 1.92. Calculate that, and then we distract the difference. So I just meant to show you this. And now I'm going to show you how it looks like with an interaction term. So we have with an interaction term, it's essentially the same story. So you basically get just more parameters, right? So your summary model 2, your summary model 2 is essentially having 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And you essentially only need you need to include this in the same fashion. So you get 0, 1 for treatment, 0, 0, 0, 0 for only getting treatment. If you want the interaction term, you need 0, 1, 1, 1, 1. Right? So we need treat and cocaine. We need 0 heroin. We need the cocaine again. We need the interaction term, and we don't need the heroin. And we put the difference. Okay. Good. And this is how you're going to do lab class 9. And so I did not do the heroin, so please put this in RMD file. Submit the final RMD file with the code, and PDF. If it's more than one file, just zip it and submit it via Blackboard. All right, thanks so much, and have a great week. We'll see you talk next week.